Welcome student to the next lecture of halogen derivatives. Today is lecture number 14 and I hope it is the last lecture for the chapter. Okay, and in today's lecture we'll be doing electrophilic substitution in aryl halide. Okay, in last lecture we have seen when I take aryl halide, then the electron density is found to be more at ortho and para position, right? Remember this. Okay, now today's first lecture is halogenation, and we have to understand this is electrophilic substitution, right? Okay, now let's see. I take chlorobenzene and I treat this chlorobenzene with chlorine, right, in the presence of anhydrous FeCl3. Now what happened anhydrous FeCl3? This FeCl3 actually act as what? It acts as a Lewis acid. It acts as a Lewis acid, right? So it when I say acid, it has tendency to take the electrons, right? Now what happened? See, chlorine and chlorine is present, right? So FeCl3 takes this chlorine, and not only take this chlorine, but this chlorine also takes the electron, so it becomes Cl minus, and then this FeCl3 combines with Cl minus to form FeCl4 minus, right? This is what happens, and this chlorine will become positive. Since it has become, chlorine has become positive, that means it has become what? It has become electrophile. Electrophile is what? Electrophile is electron loving. Since it is positive, it is in need of electron, that's why it is electrophile. Now electrophile is going to attack to the electron rich center, and we have studied last lecture that ortho position, para positions are what? They are partially negative, sorry, not positive, partially negative. This is negative. Okay, so this positive is going to attack either on the ortho position or para position or both. Okay, so what will be the product? Product can be like this. One chlorine is already there, second chlorine comes over here. Also the chlorine can come to para position. This will be 1,2-dichlorobenzene. This will be 1, 2, 3, 4. This is 1, 2, 1, 2 dichlorobenzene, 1, 2 dichlorobenzene. This will be what? This will be 1, 4 dichlorobenzene, right student? Okay, understood the name? Simple. Now in the same manner we do the next reaction, that is nitration. Now what happened in nitration? Again we take chlorobenzene and I treat this with nitric acid, HNO3, and that too in the presence of conc H2SO4, that is concentrated H2SO4. Okay, this is needed student, and this combination is called nitrating mixture. If you remember, we have done this in 11th. This mixture is called as nitrating mixture. Okay, and when we treat this, what is formed? The product form again can there's a nitro group is formed, that is NO2 plus. This NO2 plus either track on the ortho or on the para or both, right? One thing more, but first let's complete the reaction. Cl, here comes NO2, plus Cl, here comes NO2, right? Now student, out of this, which will be the major product? Which will be the major and which will be minor? See, the one which is present at the para position is always major product, because if they are very close to each other, there can be somewhat hindrance, there can be some of repulsion between them, right? So if repulsion is there, somewhat repulsion is there, that means there is a less stability. So if less stability, less product. So always para position will be the one which will have major product until unless there is the attraction between the orthos. Okay, so this is going to be major product. Similarly, this is also going to be what? Major. And obviously this is going to be minor, right? This is minor. Can you tell me the name? What will be the name? 1-chloro-2-nitro-benzene. What is the name? 1, this will be 1, this is 2, 1-chloro-2-nitrobenzene. This will be 1, 2, 3, 4. 1-chloro-4-nitrobenzene, right? Now, if you understand, we try to understand the mechanism of this, okay, then let's understand how it is going to be. You know the structure of HNO3. Okay, let's see. N is there with a double bond. It's somewhat like this. Okay, this is a structure of HNO3, nitric acid. Okay, 1 hydrogen, 1 nitrogen, and 3 oxygen. Also, we know the structure of sulfuric acid, S double bond O double bond O, OH, OH. Now understand student, sulfuric acid is more stronger acid in comparison to nitric acid. So this sulfuric acid donates a proton. When it donates a proton, it becomes what? It becomes O minus, and this comes out as what? H plus. So that H plus which comes out, we know this has a lone pair of electron. This H plus which is given by sulfuric acid comes over here. When it comes over here, it forms a bond with that H. Okay, but to form a bond, oxygen has to supply this electron because it was H plus, it has no electron. So when this oxygen gives, it acquires a positive charge. Now, when we know or we understand oxygen is a more electronegative atom, it can't remain positive. So it tends to take the electron from here. When it comes out, it becomes H2O, water. And what it results in the formation? It is in the formation of N double bond O with a positive charge, right? This is called Nitrogroup. So what is formed, student? Here is a formation of electrophile, and this electrophile is obviously going to attack either at the ortho position or at the para position. So we get this compound. So it's very important to understand how this electrophile is generated. So here sulfuric acid actually gives H plus, that H plus combined with nitric acid to form nitro group, and water is given out. And that water, because here H plus is given, right? So that water again give that H plus, and that H plus again will react with nitric acid, and so the reaction continues, right? Clear? Okay. Now, moving further. Next reaction is, we have done halogenation, we have done nitration, next is sulfonation. Sulfonation. Right. Now, what happened in sulfonation? Same way, suppose I take chlorobenzene and I treat this with H2SO4, fuming means concentrated H2SO4. Okay, now what happened? It results, see here, this H2SO4, actually from here electrophile is generated. And what is that electrophile? We have to understand that. Here comes Cl, here SO3H, benzene sulfonic acid, right? This will be one, this will be 2-chlorobenzene sulfonic acid. This is 1, this is 2. So 2-chlorobenzene sulfonic acid. Similarly, also at the which position? Tell me. Para position. So 1, 2, 3, 4, right? 4-chlorobenzene sulfonic acid. What will the name? 4-chlorobenzene sulfonic acid. I hope this is clear, student. Now again the question comes, so how this SO3H plus is generated? Right, that is very simple, student. Let's understand. We have sulfuric acid, right? Structures like this. There are lots many sulfuric acid because it acts as what? Reagent, right? So there's lots many sulfuric acid. I'm taking 2 moles of sulfuric acid, suppose. So this is the second mole of sulfuric acid. 1 mole, second mole. 1 mole of sulfuric acid. Suppose this sulfuric acid generate H plus. So this H plus is going to come at oxygen in the same way how it was in nitric acid. So when it comes, it forms a bond, it becomes plus, electron is given out from here, so S acquires positive charge, right? So what we generate? We generate S double bond O double bond O OH with a positive charge, and this positive charge either attack at ortho or para, SO3H. I hope this is clear and simple. Right, so this is sulfonation. Okay, and next reaction is Friedel reaction. In this there are actually 2. One is alkylation, other is acylation. Okay, Friedel reaction. I take Cl, treat this with CH3, Cl, anhydrous AlCl3. That is very important, student. This AlCl3 combines with the Cl to form ACl4, right? As we do in halogenation. So when it becomes AlCl4, this will acquire positive charge, and this positive charge is going to attack. Got that? Is it clear? AlCl3 is going to combine with the Cl to form AlCl4. This becomes positive charge. This positive charge is going to attack either on the ortho or in the para position. Right. So I will get this product. CH3, or I can get. Now, what is the name of this, student? If you remember, what is this called? This is called toluene. What is this called? This is called toluene, right? And we have chlorine over here, right? So this is called 2-chlorotoluene, because this is going to be 1 second. So 2-chlorotoluene, right? And this will be suppose this is 1, this is 2, this is 1, 2, 3, 4. So this will be 2-chlorotoluene, and this is be 4-chlorotoluene. Right? Clear and simple. I hope you understood this part. Okay, now that was alkylation, and next reaction is acylation, where we add actually acyl group. Okay, this is acylation. Chlorobenzene, I treat this CH3 C double bond O Cl. Right. What is this? This is acetyl chloride. Okay. Again, in the presence of anhydrous AlCl3, this AlCl3 is going to take this. We get a positive on this part. Right. You hope this is clear. So this will become positive, and this positive going to attack either on the ortho or on the para position. So simple. So we get a two product right here. Cl C double bond O CH3, this is one. Cl C double bond O CH3. Now, very important, what will be the name of this student? Tell me the name. This is called 2-chloro. See, this is 1, this is 2, right? And this I call what? The name of, what is the name of this? This is called acetophenone, and at the second position chlorine is present, so this was called 2-chloroacetophenone. Is it clear? What is this called? This is called 2-chloroacetophenone. And one thing mostly in our textbook they have written 1-chloroacetophenone. That is wrong. And also 1-chlorotoluene. That is also wrong. It's a 2. Okay, so make that correction in textbook, right? So it says 2-chloroacetophenone. 2-chloroacetophenone. Now, how this name you have to remember? See, first of all, here there's a phenyl group, so there's called phene. There's a ketonic group, so that's why ONE, phenol. And this group is called acetyl group, student, right? 2 carbon, so this group is called acetyl group. So aceto, right? And at the second position there's a chlorine, so 2-chloroacetophenone. And what is the name of this? 1, 2, 3, 4. So it will be 4-chloroacetophenone. Right? Clear? Okay. So here we completed all the important and the reaction part. Students, next part will be your homework. I mean that you have to do by your own self. Okay, this is uses and its effect on environment of these some poly compounds. That compounds are CH2Cl2 methylene dichloride. That compound can be CHCl3, that is chloroform. That compound can be CHI3, that is iodoform. That compound can be CCl4, right? Or DDT. That compound is what? DDT. Okay, so these are some compounds of alkyl halide, and there are lots of uses of this. So your homework will be, right, you have to study the uses of this. That's very simple. This is theoretical part, does not require much explanation. So I'm leaving this on to you, right? Read that. It's very simple. If you don't understand, you can always ask. Okay, so student, we have today we are lectures completed, and also we have completed the chapter. Thanks for watching, student. So chapter completes. Bye.